Hello, welcome. Again, we are covering the subject compressible fluid flow for civil service mains IFS and Gate Aerospace exam, and we are studying the topic shock collars from the chapter Oblique shock and extension waves. And in the shock collar, we in the last video we studied that it is a graphical representation of oblique shock, and we considered an oblique shock. This is oblique shock wave, and the velocity velocity uh, ahead of shock is v1, and after shock is your v2, and velocity before shock is in the x direction, and after shock it is depicted by an angle theta b, which is your deflection angle. And graphically we represented the condition before the shock by point A or OA, that is V1, and after shock it is represented by point B or OB is your V2. Okay, and on x-axis we represented the velocity in x direction, and on y-axis we represented the velocity in y direction. So the initial velocity contains only the velocity in x direction, whereas the final velocity contains the velocity in both um, x and y direction. Final velocity component in x direction is vx2, and in y direction it is vy2. So this is for angle theta b. Now if the angle is increased, then there is different v2 or the velocity after shock, and there is different point c. Okay, so this is the point uh, in the shock polar, then the angle is theta c. Similarly, for different angles we can choose other point. For this point, this point, so all these points make the shock polar. So this is OA is uh, the condition before shock, and all these points on this graph represent the condition after shock for different angles. So this is called shock polar. Okay, and this is in terms of velocity. Now we will non-dimensionalize the things. So here, if we, as shock is an adiabatic process, so A star or characteristic velocity will remain same before and after shock. So we can divide this velocity v1 by A star as well as velocity v2 by A star, because A star is same, and then can draw the graph. Okay. So then by this way we can dimensionalize the non-dimensionalize the things. Okay. So this is the graph. So here we have divided VA or Vx by A star and Vy also by V star. So your this is the condition before shock OA in terms of non-dimensionalization term, and this is the condition after shock, and this is your shock polar in non-dimensionalized form. Okay. So this is for angle theta b, and same way this is the this may be the angle for maybe for angle theta c or different angles. Okay, so this is your shock polar. So here at point B or on the right part of the curve, the velocity is your supersonic. So here this is supersonic, this is supersonic, this is supersonic, this is supersonic. Up to that the velocity is supersonic. So it means it represents weak shock. And here the angle is here the angle is theta, so this angle can be the maximum angle. This is your theta maximum. So there will be no solution for angle more than theta max. Okay. So this represents weak shock solution, whereas this curve represents strong shock solution. Okay. And if we take m star or m star is equal to 1 and draw a circle, so this is the circle. So within this circle the velocities are subsonic. So if we take this point D, the velocity is subsonic, it is strong shock. If we take this velocity E, it is also subsonic. If we take this point, the velocity will also be subsonic. At this point, the velocity will be sonic. On this uh, circle, the velocity will be sonic, and this is called conic circle. And so it means these are the points of supersonic velocity, or the points of beat shoot, and this is the points of strong shoot. Okay. So now if we take point A, that is the initial condition, and if we take point B, that is the final condition, and draw a line like this, and then draw a perpendicular which is passing through origin. Okay. And then the angle, this angle made is called wave angle or shock wave angle. So this is your shock wave angle. Okay. So these are the observations from the uh, shock collar diagram. Now I will read all the points one by one. Okay. So this one more thing. So this OA, for OA initial velocity, if we take point, if we take this OE, then the angle, then this theta angle will be 0, because this is the initial condition OA, and OE is the final condition that represents normal shock. Okay. So this is if we start increasing angle, then it will be oblique shock. So I will read all these points one by one after this. We have studied this in the last video. Now starting from this. For convenience, let us non-dimensionalize the velocities in figure C by A star. As the flow across is adiabatic, hence A star is same ahead of and behind the shock. Consequently, we obtain the shock collar, which is locus of all possible M2 star. The values of for given M1 star as shown in figure D. The convenience of using M1 M star instead of M or B. To plot the shock collar in that as M infinity, M tends to infinity, M star tends to 2.5, because M can be infinity, but for the value of infinity, for the value of M as infinity, the value of M star will reach only up to 2.45. Okay. So this is the, so we can draw it only on the paper also. So hence the shock collar for a wide range of Mach numbers fit completely on the same page when plotted in terms of M star. Also note that a circle of radius M star defines the M star is equal to 1 defines the sonic circle. Inside the circle all velocities are subsonic, and outside it all velocities are